Today we'll add, subtract, multiply, and divide radical expressions. So like radicals are radicals that have the same index and radicand. So if we look at our example here, the cube root of 5 and the 4 times the cube root of 5 are like radicals because they both have an index of 3 and they have the same number underneath the radical. So if we look at the table, radicals with numbers, notice we have a square root 2 plus a 3 square root 2. Well, I want you to think of this as like x plus 3x. And we know from back in the day that would be like 4x. But instead of putting an x, we're going to use the square root 2. So 1 square root 2 plus 3 square root 2 is really like 4 square root 2. If we look at the next one, notice we have 2 cube root of 7 minus 4 cube root of 7. Well, think of it as like 2x minus 4x. And we're going to say negative 2 cube root of 7. The same is true with variables. Okay, so if I have the square root of 5xy plus 8 square root of 5xy, think of it as everything underneath the radical as long as it matches. Think of it as like a general variable. So 1 plus 8, we would have 9 square root of 5xy. That's it. If we have 3 times the 4th root of 9x squared y minus the 4th root of 9x squared y, that would be 2 4th root of 9x squared y. So when we are combining radical expressions with add or subtract, notice it's almost like they took our two numbers in front of the radical and factored them out. The same thing is true with subtraction. Okay? So if we want to find the simplified form of each radical expression in our next example, notice we have 3 square root 5x minus 2 square root 5x. This would be 3 minus 2, which would be 1 square root 5x. And that's it. For letter B, notice we have 14a square root of 7bc plus 5a times 7 square root of 7bc. So we have our like terms. Notice we have these guys match, and what's underneath the radicals match, and they're the same index. So 14a plus 5a would be 19a, and then square root of 7bc. And that's it. Done. If we look at letter C, notice we have 3. We have a 5th root of x, but we have a 5th root of 3x. So because underneath the radicals those do not match, we actually cannot add. I want you to take a minute or two and try the 3 example u-trays. So hopefully for A, you found that you cannot subtract those because they don't have the same index or root. Letter B, 7x square root xy, and letter C, 2 5th root of 3x squared. That brings us to our next type of problem. Notice it says, what is the simplest form of the cube root of 250 plus the cube root of 54 minus the cube root of 16? Well, in order for us to do this problem, the first thing we have to do is do some factor trees to break down the radicals as much as we possibly can. Notice 250, you know it ends in zeros, so we can break it down to 10 and 25. 25 breaks into 5s and 10 breaks into 5 and 2. Now, remember, if I have a cube root, that means I need 3 of the same in order for us to come out of the radical. So this one would actually be 5 cube root of 2. We're going to do a similar process for 54. So notice this time we have 9 times 6 is 54. 9 breaks into 3 and 3. 6 breaks down to 3 and 2. And we have a cube root, which means I want 3 of the same number to come out of the radical. So we'll have plus 3 cube root of 2. We're going to use a similar process for the cube root of 16. Now remember, 16 breaks down to 4s, which breaks into 2s. And notice we have a cube root again. We have 3 2s, so we'll have minus 2 cube root of 2. Now, remember the trick to these. is we have to have the same number under the radical and the same type of root. So because all three of them have cube root of 2, think of this as like 5x plus 3x minus 2x. Okay, so 5 plus 3 minus 2 is 6. So our final answer is 6 cube root of 2. That's it. Take a minute or two and try the example you tried. What you will end up with this one is just 0. 2 minus 5 is negative 3 plus 3 is 0. So it's just 0. Notice what we're going to do in this next one is we're going to multiply our radical binomials. We're just going to distribute just like we would if we were working with variables. Okay, so we know we'll have 1 times 4, that's 4. 1 times negative 3 square root 7 is negative 3 square root 7. 2 square root 7 times 4 is positive 8 square root 7. And 2 square root 7 times negative 3 square root 7, think of it as 2 times negative 3, which is negative 6. And square root 7 times square root 7 is just 7. And then we just simplify it. So we know we can add together this guy with this guy because they have the same radical and they have the same number underneath the radical. Okay, so we'll know we'll have 4 plus 5 square root 7, and negative 6 times 7 is negative 42. 4 minus 42 is negative 38. And so our final answer is negative 38 plus 5 square root 7. We're going to follow the same process for letter B. So we'll do 5 times 5, which is 25. 5 times negative 3 square root 2 is negative 15 square root 2. 3 square root 2 times 5 is 15 square root 2. And 3 square root 2 times negative 3 square root 2, well, I do 3 times negative 3, which is negative 9. And square root 2 times square root 2 is just 2, and those are multiplied together. So just like we discussed earlier, notice we have like terms here, and we know negative 15 plus 15 is just 0. So all we have left is 25 minus 18, which in this case is 7. And that's it. Take a minute or two and try the 2 example U-tries. So hopefully for A, you found 46 plus 16 square root 5, and for letter B, 24. Okay, so what we're going to do next is we're going to rationalize, meaning we're going to have radical expressions in the denominator of a fraction. So notice we are going to multiply the numerator and denominator by the conjugate of the denominator. This is no different than when we did with the i's and when we did the synthetic division with i's and radicals. So remember the conjugate, I'm going to keep the same first and end number. I'm just going to change the sign between. So in our thinking bubble, the conjugate says 6 minus the square root 3. That's actually what we'll be multiplying numerator and denominator by. So we're going to multiply the numerator and denominator by 6 minus the square root of 3. And now we're going to distribute, also known as FOIL, numerator and denominator. So 66 minus 11 square root 3, and now we'll do the same thing with the denominator. 6 times 6 is 36. 6 times negative square root 3 is negative 6 square root 3. Square root 3 times 6 is positive 6 square root 3, and square root 3 times negative square root 3 is just negative 3. Numerator still remains 66 minus 11 square root 3. Denominator, the 6 square root 3's cancel out, and we have 33. Now we're going to ask ourselves what number goes into all three. And when we say all three, what we mean is we mean the 66, the 11, and the 33. What number goes into all three? Hopefully we recognize 11. So 66 divided by 11 is 6. Oh, wrong thing. 6. 11 divided by 11, we'll have negative square root 3. And the denominator will just be 3. Now technically you can clean that up a little bit more. This would be deemed acceptable. Or what you can do is you can say 6 over 3 minus square root 3 over 3, which is 2 minus the square root of 3 over 3. Both answers would be deemed acceptable. I want you to take a couple minutes and try both example U-tries. Okay, so hopefully for A, you have the square root of 35 minus the square root of 21. Notice in the numerator, the square root signs do not go away because they don't match underneath the radical. And for letter B, you have 12 plus 4 square root 6 all over 3, or you have 4 plus 4 square root 6 divided by 3, only underneath the radical. And you are ready to do some practice. The end.